Hi, Sean. Sean, you still there?
Yeah.
Wait, give me a sec before. Hi, everyone. I'm Matteo Collina, and I work for a company called Nearform. You probably have heard about this Node Week from us, really. So I'm here to talk today about the cost of logging. Now, this story begins in London. And I was down there with my colleague, David Mark-Clemens, and we were doing one of our flagship training course, which is a performance training. And David will be talking a bit more about performance during Node Week as well. So, and this story, so we were down there doing our flagship performance training course at a customer. And well, we have got this nice idea of a new logger, but let's get into that for a second. We were down there at Net-A-Porter and Mr. Porter, and what we did there was 2 days of training and 2 days of consultancy. So what they reached after 3 months' time, in 3 months, after they applied all what they was learned and what we discussed during those 2 days and 2 days, those 4 days, that they were able to reduce the number of servers to 1/3, double the throughput, and halve the latency, all at the same time. So all in all, maybe it was a 6 times, 8 times, maybe throughput and performance improvement overall. Very nice indeed. So during that workshop, during the training plus consultancy engagement, our friends asked a nice question. So, well, if we disable logging, we could increase throughput by a whole lot. Why is that what's happening? Okay. Well, first of all, let's just discuss what is the problem of logging. Okay. So there's a bug, and in the middle of the night, really, or a Saturday morning, I got a couple of nice phone calls at 7 a.m. on Sundays. Really, I don't know why Sundays, but I don't know. So there's a bug, and because of that bug, you add some lots in, so you can then are now able to fix the bug. Hooray! We can fix the bug. However, and because of this, there is the general wisdom that the more you log, the better. Now, you can actually do you can end up doing quite a lot of logging, in fact, because it's just one log line, okay? So you can just say, well, this is just one little log line. What can that mean, okay? So why bother? I can add as many as I want, really. Really? Not really. So if logging a line will take you some chunk of a millisecond, some chunk of it in most frameworks. So there's an actual time spent logging a line. Well, can you measure less than a millisecond? Can you measure a millisecond? Well, let's run some math before saying this is 0. Okay, we can approximate this to 0, yes, but it's not 0. Let's run some math. Let's just say we want to do 2,000 requests per second. And we have just discovered that logging a single log line takes 0.22 milliseconds, which, if we multiply it by 2,000 requests per second, comes out with 440 milliseconds just for logging. Okay, so we are spending so if we want to do 2,000 requests per second, what we are saying is that we are actually spending almost half a second just for logging lines. Whoa, this might be a little bit crazy, okay? But if we want to say that for each log line, we are doing 10, for each request, we are logging 10 lines, well, there might be a bug in production or something that we want to have the debug logs. Whoa, what's happening here? We are up to 4 seconds, more than 4 seconds, which is more than 1 second. So our logging became automatically our bottleneck. to reach the target of 2,000 requests per second. Kaboom! This is a nice slide, okay? In person, it was way better, but again, I hope we can convey the feeling, your feeling at this moment with this nice slide. So the big question here is why it's so slow, okay? Why this specific is slow? Well, because of what I define, I call it the adapters problem, okay? Now, I shot this picture myself with my camera at my house, my whole house, last summer. So, and it depicts the typical problem in software those days. So what you have is that in order to fit a plug, you can stack up a lot of different adapters to it, like, you know, like the new MacBooks with all the adapters for the adapters for the adapters. Anyway, and the plugs is the most widespread legacy system, why we can't have a single proud word, okay? Well, every country wanted its own. So, hey, we have got everybody has a new standard. So the whole thing is all about adapters. So there's this thing that you can fold a piece of paper only a limited amount of times before it becomes too hard to do, okay? You can create, even if you can create adapters of adapters of adapters of adapters of adapters, after a certain level, the overhead of all those adapters will actually slow you down greatly. So we had this nice idea. Oh, and by the way, why we are saying all those adapters in software? Well, when you are logging something, you are actually writing, you are calling log.info, for example. That usually might have to do, oh, well, maybe I need to decide if that thing is enabled. Then I need to go through the side where it needs to go. So that goes to a file descriptor. That goes to a file. Then I need to encode it, and then, well, there is that, and there is the streams, and there is a lot of all those little steps. And in fact, one of the logging framework can add more because, you know, oh, well, I might do log rotation, and it's one more step, one more adapter, because the generic logging interface needs to be wrapped to do log rotation as well, and so on and so forth. So we had this nice idea back in London. Let's write a fast logger, really a fast one, okay? And Pino was born. Thank Bob for the for the logo, by the way. It's fantastic. So Pino at Nearform, we love JSON, and we love new line delimited JSON, in fact, which is this nice /n here. You know, new line delimited JSON is fantastic because it's easy to process and it's easy to forward, and we can easily put it in on Elasticsearch, for example. So, and we can easily parse it using split2. This is one of my favorite modules. Well, I wrote it, I copied from my friend Dominic, but it's this is called split2. It's the stream2 API for split, which is another very popular module. Anyway, and Pino was born. We are huge fans of Bunyan, by the way. So Bunyan, Pino has the same API of Bunyan. You can require Pino, you instantiate it, just calling a function, calling info or debug or whatever level you want. And with Pino, you can do 10,000 operations in 250 milliseconds, more or less. Depending on your machine, mileage may vary, but that's what it is. This is out of the box. It can do 10,000 operations in 250 milliseconds, which means, really, it's an order of magnitude lower than the other framework that they were using. So if we multiply 0.25 millisecond 2 times to 2,000, you get 50 milliseconds, which is fine, very easy to handle 200,000 2,000 requests per second. Okay, we are left with a 950 milliseconds for all our operations, which is good. And even if we log 10 log lines for each request, we can still have plenty of time, like 500 milliseconds, half a second for doing all our processing, which is good. Now, this diagram shows stats Pino against the other loggers and similar stuff you might have. We have Banyan, we have Winston, we have Digag, and we have Pino, and there is benchmark for all the rest on our website. Okay. As you can see, there is some overhead in the other ones. Okay, Pino is built for having no overhead whatsoever. In fact, we can even go faster. We want to go faster, right? There is a little bit of catch there. In extreme mode, we can get 10,000 log lines in 100 milliseconds. More or less at 2 times more, 2.5 throughput increase. Whoa, this is fantastic, okay? In fact, if you run our numbers, yeah, we can really do 10 log lines for each request very easily now. The trade-off is a 4 kilobyte batching. So what we batch 4 kilobytes of data before flushing. So you might lose 4 kilobytes of log, a worst case scenario. This is unfortunate, but it needs to happen. Okay, that's a trade-off. And how do you enable it? You just pass extreme true to the constructor of Pino, and you're done. That's it. Very easy, but that changes how Pino works pretty heavily. So when we develop Pino, we noticed that even though the logger themselves were kind of okay, a lot of the problems were in the integration with the frameworks. So what we did, we developed the integration with for the more popular framework ourselves. So what we developed, for example, is Express Pino Logger. Express Pino Logger, you just instantiate it, pass it through, just works really fast, no big deal. There is for Happy, and for Happy you need to install your service, and then register a plugin, and it will just work. We do this because there was this big question around what we discovered was that good was introducing too much overhead for our purposes, so we cut that. Okay, so it's way faster than good. And you can use either the standard good interface, or you can interact with a single logger. By the way, in Pino, each logger, in all the integration, each logger is a new instance of the logger itself that set the ID, a request ID, so you can track down all the log lines. So if you pass down the same instance of the logger, you can track down what happened for that specific request, which is super handy when you need to debug a production system. Of course, we have a Restify middleware, and a Koa 1 as well. Koa 1 and Koa 2, come on. If you're into Koa, that's a really good one. In fact, most of those are powered by our Pino HTTP logger, which is very handy, very easy to use if you're not using any framework. I tend to code MedScience stuff a lot of the time, so I just use stock HTTP or something. So if you're into that, you can use Pino HTTP. So let's go back into the secret sauce and how we were able to squeeze 10,000 log lines in 100 milliseconds. So first thing, avoid JSON stringify. Do you think I'm mad? Probably. So JSON stringify, it's quite a heavy operation. Okay, it involves recursing a lot of a tree. Now, the nice thing about this is that we can predict that most of the log lines share the same content. So we don't need to redo all of that all the time. So we don't do that. We just cache most of the log line, like the process ID, the levels, all those things. It's already done, rendered, so we don't have to re-render them all the time, and that saves us a lot of time. Also, we don't use new date to ISO string. Well, that was really slow, really. Like putting in there an epoch time, a time in epoch, it's way, way, way faster than an ISO string. Like to ISO string is a super slow method, really, super slow. So don't do that. Finally, well, this is a crazy one, okay? So we even tweaked, we went down one level and we discovered that we were spending a lot of time traversing strings. So we discovered how to tell V8 to allocate our concatenated string in a single contiguous chunk of memory, which is in fact done in this method called flatString. And what you can see in flatString is that flatString is itself implemented in very easily with this nice constructor here. Yes. So there is a full explanation here of why it happens, but there is a huge difference between the two. Okay, huge difference. Okay, so. And this is all the explanation. So the basic thing is that a string in V8 can be represented as an array or as a tree. And yeah, well, probably Dave will speak a bit more about this in the next talk. So this is it. Then there is another story. Given that we log in JSON and we support random JSON object, we still need to stringify things. And because we still need to stringify things, we are in fact using this module, this technique that David found out and I slightly improved, which is fast, safe stringify. Now, fast, safe stringify allows you to stringify safely, meaning that if you call JSON stringify on an object that has regular circular data structure, that there's a circular data structure, it will throw an exception right now. With fast, safe stringify, it won't happen. And there are other methods called safe stringify or whatever. This approach uses a very, very hacky way to do so. So we create this circle object and we replace the original value with the circle object, and we call toJSON. With this circle object, implement a toJSON method, which is what is called to render a specific element of JSON by the JSON stringify function. So, and that returns circular. So that's where the magic happened, and this is what it replaces itself in the parent. Yes, it's hacky, okay, very hacky, but it works very well. So one more trick was we implemented our own formatting rules. So remember that printf thingy. We implemented it because the one in core in Node 4 had a bug, so that was one of the problems, a performance bug. That was one of the problem. The other problem was it needed to be called with apply, while we wanted to call it with an array because that's what we were getting for some reason. So that we built it more or less. So so how we discovered all of this? So now the big question is how we go. We went and go to discover all of those secret shows and how we developed Pino and which tool we were using while developing Pino itself. So what we did, we developed a lot of flame graphs. We used a lot of flame graphs. In fact, we wrote this tool called 0x, okay, and we did it in we did the core of this in London, okay. So it's quite a nice tool, and you can see it here, and I will show you a demo. This will help you highlight automatically which is the bottleneck, or which are the bottlenecks of your application. So and in fact, this is where we discussed stringify. So you can see that this is the first one. This is JSON stringify. We see that to isostring to JSON. You see that there is Pino, and we were here spending a lot of time doing stringifying JSON, and see that we spend a lot of time here, okay, and also a lot of time into isostring. Now, after the change, we were actually like the JSON thing disappeared completely, and we were just spending time here and in writing to buffers, which is a really good one. And this is a second pull request that was done to Pino, so really handy stuff. Okay, so this is before, as we have seen, JSON.js. This is from V8, and this is after. Okay, so this completely went away. So another thing that we were developing at the same time, more or less, or slightly after, actually, I'm about to say, is called autocannon. is an HTTP 1.1 load tester, and it's trivial to install in cross-platform. It supports Node 4, 6, and 7 on Windows as well, very easily. Generates more load than alternative written in C if you have enough CPU power and so on. Really good. If you can combine those two, you have a full performance stack written in Node, which is very cool. So now it's time for my demo. Okay, so let's do the demo. So let's create some reference. Okay, let's go into Elastic, not Elastic actually, that's the second demo. Let's go into Express. So in the Express folder we have several files. First of all, let's see the raw server. Raw server is just HTTP, it's just an HTTP thing. Okay. Now I wrote this nice little script that just run the thing and call autocannon. So I'm doing .bench raw server, and it's running it, and we will see some numbers out of it. So let's see. Now, without anything on this machine, also with the streaming stuff enabled, so probably slightly more, we can get 21,000 requests per second out of the box in an hello world with Node. Okay. Now, let's see with Express, because a lot of people will use Express really. So let's use Express. Let's see how Express does it. Okay. Now Express can do 8,200. Whoa, that went down quite a bit. Anyway, let's introduce Banyan. Okay, so that was Express. Let's introduce Banyan. So we use Express Banyan logger. So let's do bench Express Banyan. No, that's another file. Banyan server. So now it's running. It's generating 100 connections with 10 pipelining factor. Whoa, the Banyan one went down to almost to roughly 2,000 requests per second. That's big. Okay, it went down quite a bit. Now let's see the Pino one. The Pino one it has the same APIs, can use the same way than the Banyan one, but let's see with Pino. So with Pino we can get almost 5,800. So just by switching from Banyan to Pino, you can get more than twice the throughput out of your system. Okay, more actually, almost 3 times the throughput without changing anything else. Actually, we can also check how Winston does it, because you see a lot of other people use Winston, so we say, oh, Winston is faster. Winston is slightly faster than Banyan, still not as fast as Pino at all, completely in a completely different realm. Okay, so this is it. Let's go back to here. Also, what I can show you is, in fact, generating a flame graph. So let's see. Let's use 0x to generate a flame graph of the Banyan server. So you run 0x Banyan server. You enter your password, which I'm not. Whoa, yeah, no worries. That because I had modules installed with Node before. It's not a big deal. Now it's profiling. Now what I need to do is it's use autocannon. So autocannon -C100 -D5 -P10 localhost 3000. Now it's running. Whoa, you can see here. This did a big mistake. Okay. So first of all, let me rebuild. Yeah. Sorry. So let's open the profile. Okay. Yeah. So. Yeah, well, let's run it this way. Banyan server, dev null, so we don't see any of those silly errors. And yeah, we saw them anyway. So, but again, we're not seeing the logs. So, whoop. Yep. So that's done. We enter Ctrl+C here. So we cut singing. We're generating some flame graphs. We can open them. Yep, and here we go. This is our this is done with Banyan. Now we can see that the most crazy part of all of this is this regular expression, which is the 3.52% at the top. which comes down from the user agent module. And there is a 2JSON serialize of all of that. Whoa, what's happening here? Okay. Then there is some other thing here that is really high. Anyway, refresh. It's anyway. So let's go back to my demo. Well, yeah. So Pino is more than a module. Pino is a way of life. Pino bases itself in the absolute minimum overhead for logging itself. In fact, regarding to Pino philosophy, the Pino philosophy, it means that you're going to rotate your log yourself. How do you do that? Okay, it's very easy, super easy to rotate your logs. In fact, you can add to the Pino thing, to the Pino GitHub repo, and you can what it is, transports. Nope. We changed all of this. So where it is? Big question. Now I don't know where these things are. Here it is. How to use. Okay, how to rotate log files. Okay, so you rotate using log rotate. Now log rotate has been there since forever, and is part of your Linux distribution. It has been this file here. Was touched 11 years ago. Okay, so this tool is rock solid. Why do you need to write a thing to rotate logs yourself? Just use log rotate. Okay, so you don't need to do anything. You just you can do it for you. So, well, the other thing is, given that we need to do some from time to time, Pino, we might want to have a better logging, because that's ULI delimited JSON really. So it's not really easy to read for humans. So we can post-process it with the Pino's command line utility, so that you can, in fact, do something like node express server Pino, and then curl localhost 3000. Whoop. Oh, that's the first one. Nice. Pino server. And you can see here it's a nice little thing compared to this, which is a less nice thing. Okay, we can all agree that. So also transport are separate processes. So what I mean this is Pino only writes to either to a socket or a file descriptor, more or less, to a socket or a file or something like that. It doesn't do anything fancy, because we don't want to run into the adapter problem. Oh, I see a question there. I will reply that in a moment. So in fact, now we are going to demo our Pino Elasticsearch, the ELK integration. So let's clear this up. So let's go join the other demo, which is Elastic. So cd Elastic, and now for this we are going to use Docker Compose. So we do a Docker Compose app to bring up our cluster with Elasticsearch and Kibana. Okay. Now all of these are booting, so it will take a second to do that. So because of this, we might be able local. Oh, wait a second. Cat, readme. I am very bad. 5610. 5610. Yes, I can never remember this. Now, Kibana is booting. So this is Kibana. It has nothing here. So we need to start our app. So what we do is we open up our app and run node Pino server Pino Elasticsearch. Okay. Here we go. Then we curl it. Hey! Now we can refresh this one, and what you will see is if you type in Pino here, you will see that automatically gets prefetched, and it says time field name time. Perfect. We create our index. Now we can go to discover and see that was one log line, which is our call. Here we go. that was quite a nice one. Okay, as you can see here, we get the remote port, the PID of the process, the host name. Hi, that was my thing. Not really, you can't really reach me here. But again, I'm connected via Telecom Italia. I don't really want to make a spot for them. There is also wait a second, an ID, a request ID, which is that number I was telling you about. So let's get some numbers out of it. So let's bomb it. So we are actually bombing this. So if we refresh it, we will see that there is crunching and ending stuff. So it's adding more things here. So you can see now we have a lot of requests, loads of them. So you can search it and so on here. All the fields are available, so you can crunch it and process the way you want. So during Pino, the development of Pino, we had some very good ecosystem impact. In fact, we tweet about this to all the relevant log authors, and our friend Rod, which is the author of Bolly, actually said something nice, that we throw the gauntlet to him, and he basically released a new version of Bolly, which was faster than Pino. Okay, so we had to go through another round of optimization ourselves to regain our crown. So, but it was very nice. So I am, and in fact, a lot of modules right now are using fast safe stringify. Fast safe stringify is really nice. So it gets very good number of downloads, and a lot of really dependent things are using it. Okay, like everybody is using it because it's really handy because it avoids like crashing. It's super safe. You don't need to try to put a try catch around JSON stringify. So it's really cool. You should use it. You should use it yourself. Okay, it's actively developed. In fact, we released a thing 2 weeks ago. So so this presentation is available at this URL, and also and these are the source, because this is a HTML5 presentation. So this is me. Hi, this is my little wall of shame. I do a lot of open source. I work with a company called Nearform, and I help maintaining Node.js streams. So if you're using that, and probably you're passing definitely through some code written by me. I wrote Pino. I'm also maintaining MQTT.js and a bunch of other stuff. So yeah, and thank you very much. If you have any question, reach me on Twitter at Matteo Collina or at Nearform, or this my email if you want. Our website. We do consultancies, architecture review. We do developer support. We can help you with developing your projects, whatever you want, really. So I actually had a couple of questions. So let me see. So let me see. What do you think is the major performance impact in a general? What do you think is the biggest bottleneck in terms of performance in Bunyan? So that's quite a nice question. So I've run through the code in Bunyan. So there are two major problems there. So the first one is that it has all of these multiple adapters logic. So it's basically every what your logger does. It's an abstraction over another internal API that it uses to stream the thing for each level. So I think so. Basically, you can say I want all of those log lines delivered to that transport, to that to a file, and that all those log lines delivered to a socket, and you can mix and match those. While in Pino, you are fixed. Okay, and the other problem is it allocates a lot of closures. Finally, it adds this thing called a dtrace probe somewhere in there, which means that if you're in a system that runs dtrace, it will do a call to C++, the C++ layer, basically destroying the performance of your thing. So there is another question here. Oh yes, of course. How do I save only a certain level to a file, and the rest somewhere else? So there is this library that I wrote called Pino. You should use it. Really, it's really nice. Basically, you can say that you want the warn log level to the warn logs file, and you do it. It just works. Okay. By the way, Pino is built on top of Clonable Readable. Another library you should definitely check out. So Clonable Readables allow you to clone streams, so it's really handy. It just works, and yeah, I developed it as part of my collaboration with Core and Streams, and it allows you to actually clone a stream. How it works? Well, it will have all the clones start streaming at the same time. That's a catch. But it works really well. It's also part of Gulp and Vinyl. So if you're using those, you're probably depending on this Gulp version 4, which is still in the making, as far as I know. So yes, that was the second question. And yeah, third question is, what do you think is the major performance impact in a general Node.js application? This is a very long one. Okay, I don't think there is a major there is one single culprit. Okay, I would have to say that a lot of people allocate a lot of closures. So the styles tend to allocate a lot of closures, and every closure you allocate is going to need to be optimized by V8, and it also affects how memory is handled, and so on. So I would say watch out for the closure thing. But on the other hand, there is a nice talk done by David McClemens as part of this series. So go watch that, and it will talk about a lot of these things in details. Thank you, folks. Bye-bye.